I believe I remember the problem. We had to factor trinomial. It was x squared plus 3x and minus 4, right? So that's what I will break as a product of two parentheses. I factor first term x squared with x multiplied by x, and then I factor -4 with a 4 times 1. And when you check and see if this works, then it will, because when you multiply the inside 4 by x, you get 4x, and on the outside, when you multiply number -4 by 4x by negative, you put together 4x and -x, you get a positive 3x. So this way you get those terms together. So looks like we always care for the inside and the outside terms, and looks like that's what we do in all of these exercises. So just for practice sake, I can try something like number 61 that wants to factor something that looks a little bit less pleasant, and I'm going to rewrite that exercise with a -z taken on the outside of the parentheses. So notice they're all negatives, so I will prepare this exercise by taking that letter z out. So we're gonna have a 12, and then 14 times y. So I change in all the signs here. So put 14 y's on the next place, and then plus 4 times y squared. And this is going to be my start for this factoring. So when I look a little closer at this exercise, I notice that looks like all of these numbers I can divide by 2. And the way to go will be to take out the common factor of 2. So also, I think that we should probably rearrange those terms. In other words, I'll put 2y to the second power on the first position, because it looks like if we have 4y squared at the end, that's not something that we used to see when we factored. So I'll start with 2y squared. On the next place, I'm going to put 7y's, because we have squared term and then a first power of y. And finally, positive number 6. So this way we can think about factoring this trinomial. And now I'm going to need to prepare the favorite pair of parentheses and put 2y multiplied by another y in the first positions. Then we're going to put the positive signs here and start to think about factors of 6. It looks like 6 can be factored as 3 multiplied by 2. So if I put 3 times 2 somehow like that, then looks like when we are going to multiply the inside product, which is 3y, and the product on the outside, which is going to be 4 times y, then 3 and 4 will exactly give us 7 in the middle. So here's the factoring, and the point is there is nothing we can factor any farther. So we've done with this exercise. So looks like we keep on factoring those so-called trinomials, 3-term expressions. And I guess the idea is to, well, try to do as many exercises as possible in this little section, because this type of factoring you will see a lot in the future. So I'm gonna do one more exercise and wonder if you had any particular questions in mind that you want me to work out. So let me try a problem number 47, for example. So this exercise wants us to take a look at the trinomial that looks like has x squared with every single term. So why don't I factor it out? So we start with taking out the common factor, and this will be x to the power of 2. So from the first one, I have b squared left. The middle one has negative 12b when I take the x squared out. And finally, the last term has positive 35 that is left out. So now we prepare the 2 parentheses, and factors of b squared will be multiplying b by another letter b. And then when you think about factors of 35, looks like it's 5 times 7, and they should both be negative. So when you multiply negative 5 by a positive number 7, then you're going to get the product that looks like minus 5b times minus 7b. And that's exactly what we have here. It's negative 5 and negative 7 that add to negative 12. So I guess it's kind of difficult to see the answer right away when you're looking at the exercise, but when you are not in a hurry and just prepare those 2 parentheses and then try to factor out your expression, then right away you get the result. So the advice here will be to, well, just do more exercises, and that's pretty much all that we're caring about here. So I'd like to look at section 5.7 that says summarize all of the factoring strategies. So it just keeps on factoring some more exercises, and it just gives us ability to do more practice here. So if I try something like exercise number 28 here with 12x squared minus 12, then looks like we're gonna take out 12, right? Looks like 12 is present in both terms. So we are going to factor it out, and notice that I wrote 1 as a 1 raised to the power of 2. So we can actually break this a little bit farther as a x minus 1 multiplied by x plus 1. Remember the formula that said when you factor the difference of two squares, then you just write this as difference multiplied by the sum. So how about exercise number 17? When you, I guess, start doing this factoring problems on your own, the more you practice, I guess, the more you get used to the process of breaking those polynomials into products of little factors. So when I'm looking at 17, then I'm going to think of the pair of parentheses, because we have a trinomial here, x squared minus 10x and plus 25. So looks like we're gonna need to factor the first and the last term, right? So the first term will be factored as x multiplied by x, and the last is 25, which is a product of two numbers, 5. And I need to put a minus because I see the negative here. So there must be another minus with a 5, because when you multiply two minuses, then you're going to get a plus for the factor of the last piece. So I can double check and see that the products of the inside terms that are negative 5x and another negative 5x will actually sum up to negative 10, and that's just what I need in here. So this last section of the chapter is something that pretty much does the same kind of exercises, and we can, I think, move on and check what's in the section 5.8 that wants us to utilize all of the ideas of factoring here in order to solve the equations. So I'm gonna try something like exercise number 11, just to keep doing the same exact procedures for the solving of equations. And when this is a z squared plus 9 times z and plus 20, well, looks like we are going to factor this left side of our equation just like we did in the previous sections as well. So z squared, a factor was a z multiplied by z. So that's, I guess, our favorite start. Now the signs inside of the parentheses will be both positives. So I can factor number 20 as a 4 multiplied by 5. So then after we factored, there is one extra step, because we have equal to 0 for both of those factors. In other words, we are going to try to solve the equation. So when you solve this equation, I'm going to set both of my factors equal to 0. And the reason why I'm doing it is because the multiplication or product of two factors, which is equal to 0, tells me that one of these factors must be 0. Because if both factors are not 0, then I never get a product equal to number 0. So we get the solutions here, and one of them is z is equal to -4, and the other will be -5. So this last section of this chapter actually adds one more step to the story. It just wants us to make the factors equal to 0, and then we produce the solutions for the exercise. And when you're looking at the answer that they provided us with, you notice that's exactly the same thing that we have found for this particular problem. So the section 5.8 talks about one extra step that makes factors equal to 0. So it doesn't really have any new ideas, but we're solving equations and we're using factorings. So let me try the problem number 25 here, the one that has denominators, the one that has fractions here. So we have 1/2 multiplied by x squared minus 5/4 multiplied by letter x. And then we also have a -1/2 that I can bring over to the left side to produce a positive 1/2, because I like to have a 0 on the other side of my equation, because what I want to do is factor and have those factors both equal to 0. Well, in this exercise, I don't like the part that deals with denominators, and in order to make my equation look nicer, I'm going to rid of this denominators, and looks like the common denominator will be number 4. So if I multiply by this common denominator both sides of my equation, then denominator 4 is going to disappear, as well as denominator 2. So I'm going to put the 2 here on the top, as well as 2 with the last term. So now I can write this as a 2x squared, and then minus 5 multiplied by x and plus 2, which is equal to 0. And this looks much better because we no longer have any denominators. And then, as usual, we're going to factor our left side of this equation. So I'm going to break 2x squared as a product of 2x and another x, and then try to factor 2 with, looks like 2 times 1. So I'm going to put 1 here in the first parentheses and 2 in the other parentheses, because when I have a product of -1 by a positive 2, then I will get that plus 2 at the end, as well as inside the parentheses, we get -x and then -4 times x that add to -5. So I guess the plan is to always factor the trinomial here, so we can set both of these factors equal to 0 again, because they're product is 0. And then I will be able to find my values of x to solve this equation and end up with something like x equal to 1/2 and then positive 2. So looks like it's another section for factoring, and we just keep on breaking down polynomials, but with extra step that says set factors equal to 0. So there are not lots of exercises here, so let me try problem number 29, and I just try to write this as a x cubed with x squared, which is equal to 0. So we go ahead and take out x squared, right? The smallest power of x will be x to the second. So when I factor this out, I'm going to have this multiplied by x plus 1. So we continue with this exercise by making both of these factors equal to 0. So that's the key part after you factored. And then you're going to write that x is equal to -1 for the other factor, for the second one. And for the first, we have x is equal to 0. So when I'm looking at the answers they provided in this exercise, it looks like they have 3 numbers here, and I just found 2. So where is the other one comes from? Well, notice that x squared equals to 0 gives us actually 2 factors, because when you have x squared, then you can factor it as x multiplied by x, and that's why they actually wrote that pair of zeros here as our solutions. So technically, you can say that x is equal to 0 for the answer, but you can also have the 2 zeros, and that'd be pretty much the same thing. So it looks like we have lots of factorings, and that's pretty much all this section is talking about. So when I check and see what happens in the next exercises set, you see that chapter 5 is finally over. So I think that next time we're going to move to the next chapter, and to chapter 6, that actually continues to do pretty much the same procedure. So I'm not going to give you a quiz today, because it just keeps on factoring the various type of expressions. Instead, I'm going to do one more little exercise from the next section that just keeps on factoring and then dealing with those factors as well. So I'll do one more problem in the section 6.1 and then let you go and enjoy the beautiful Monday that we have today. So how about exercise number 39 here? I'm going to take a look at the fraction with x squared minus 81 in its numerator and x plus 9 in the denominator. So this denominator x plus 9 could be utilized to factor the upper part, the numerator, which is a difference of two perfect squares. So it could be factored as x plus 9 multiplied by x minus 9. And this way I can cancel this same exact factor which appears on the top and the bottom. So x minus 9 will be a remaining piece for the answer. So here we have another example of factoring usage in order to simplify fractions. So I just factored and I was able to cancel my x plus 9. So I guess that's what we're going to continue with next time. And as I said, I guess it's enough for today. I hope we had enough factoring practice, and I'm glad that you were able to make it to class on Monday. So I'm going to stop this recording and let you go.